Assalamualaikum. My name is Muhammad Amzar Ali bin Mahazir and my matric number is 01 DKA 19F1159 and I'm from DKA 4E. Today I'm going to present about steel structure design. Firstly, we start with introduction. Steel designs, or most specifically is structuralist steel design, is an area of structural engineering used to design steel structure. This structure includes school, houses, bridge, commercial center, tall buildings, warehouse, aircraft, ship and stadiums. The design and use of steel frame are commonly employed in the design of steel structure. More advanced structure include steel plate and shell. In structural engineering, a structure is a body or combination of pieces of rigid bodies in space that form a fitness system for supporting loads and resisting moment. The effect of load and moments on structure are determined through structure analysis. A steel structure is composed of structure members that are made of steel, usually with standard cross-sectional profile and standard of chemical position and mechanical properties. The depth of steel beams is used in the construction of bridge is usually governed by maximum moment, and the cross section in the dam verified for shear strength, near support and lateral torsional buckling by determining the distance between transverse members connecting adjacent beams. Steel columns members must be verified as adequate to prevent buckling after axial and the moment requirements are met. For loading analysis, civil engineering structures are designed to sustain various types of loads and possible combination of loads that could act on them during their lifetime. Accurate estimation of the magnitude of this load is a very important aspect of the structure analysis process. There are local and international codes as well as research reports and documents that aid design in this regard. Structure load can be broadly classified into four groups: dead loads, live load, impact load, and environmental load. These loads are briefly described in the following section. Next is we go to dead loads. Dead loads are structural loads of the constant magnitude over time. They include the self-weight of structural members such as wall, plaster, ceiling, floor, beams, columns, and roof. Dead loads also include the loads of fixtures that are permanently attached to the structure. Prior to the analysis and design of structure, members are preliminary sized based on architectural drawings and other relevant documents, and their weight are determined using the information available in Morse codes and other civil engineering literature. The recommended weight values of some commonly used material for structure members are presented in the table 2.1. The determination of the dead load due to structural members is an iterative process during designs. Member size and weight could change, and the process repeated until the final member size is obtained that could support the member's weight and the superimposed load. Next, number 3 is live load. Live load is a civil engineering term that refers to the load that can change over time. The weight of the load is variable of shift or shift location, such as when people are walking around in the building. Anything in a building that is not fixed to the structure can result in a live load. Since it can be moved around, it also refers to the dynamic force from occupancy in intent use. They represent the transient force that can be moved through the building or act or any particular structure elements, also measured in PSF. This load include the anticipate weight of people, furniture, appliances, automobiles, movable equipment, and the like. For next is we go to the structure member designs. Structure members are the primary loads-bearing components of a buildings, and each of their own structure properties will need to be considered. Such member includes for A, beams. Horizontal member which transfer load to support. For B is a column. Vertical member which transfer compressive load to the ground. Next is C, bracing. Members are interconnect and stiffens column and beams. For next is in the roof truss. For loads bearing frame constructed of connected triangular shapes. For E is retaining walls. Support soil where a sloping side require excavation. For F is concrete slab spun horizontally between support used as a floor and sometimes as a roof system. Lastly is a G, footing, for transfer loads from the structure to the foundation. Next is conclusion and other information. For the concept of steel structure designing was obtained and understood, a building design has to be started from the top part, since a top part will only carry the loading from that area. The loading is then transferred to the lower level. Thereafter, the design for the structure on the lower level can only be started. The parameters such as shear capacity on beam, compressive resistance on column are to be checked before the section is chosen are also understood. Additionally, the merits and limitations of B steel structure were understood as well. Despite of having many merits, there are still safety measures to the steel building itself. Steel structure is known for its good ductility and ease of construction, but at the same time, it is also susceptible to corrosion and lose its strength on high temperature. Therefore, our good maintenance and care will keep the steel structure on its highest performance. To conclude, this design project was done successfully. The concept of designing steel structure was fully understood. That's all from me. Thank you.